Good evening. Can you hear me, Megan, Karen? Very good. I just started desktop sharing. Can you see the desktop okay? Very good. Let me put up the agenda. Before we start, do you have any questions? Okay. How's the team project coming? Okay. That's good, Karen. Research mode is good. Thanks, Mega. Are you guys on the same team or different teams? Same team. Okay. Well, I'll check next week and see how we're coming. Let's take a look at the calendar. Yeah, by the end of next week, you would have one more week. So you've got a good number of days. Were there any questions on our discussion on Tuesday? Okay. I did check the final exam questions, and we only have 7 so far. So I hope the people that are listening to the recording take it to heart, because that one's due in, looks like 7, 8, 9 days, something like that. 9 and, well, 10 days, counting today. Hi, Daniel. Okay, so I'm going to go over 15 with you. This will be the last chapter. These are optional and they're worth 8 points, just like our regular ones. You may do them or you may not. It's up to you if you think you wanted to get some extra points. Let's see. Oh, I know. Let me go back to the agenda. I think Karen or Mega, Karen, it might have been you, asked about the question 12. Yeah, I posted it. I don't know if you saw the discussion. I posted it to her, and this is the numbers I came out with. Were there any questions about these? Yeah, for the circular schedules, yeah. Yeah, I saw your note. Well, this one did. I think that was the only one. Let me think. I'm looking. I think that was the only one that completely goes, because it always scans in the same direction. So it has to go all the way back and scan forward. Hi, King. And quite a few people got this, and a few didn't use the $4.99. But if you think about it, you've got to include that, even though it's not going to stop, physically stop, right, until it goes all the way to the beginning of the track. It still is going to cover that number of cylinders or that number of tracks. So you got to count it. Yeah, and I think one of his PowerPoints showed that. I'm not sure about the book, what it said. I didn't look that up on this algorithm, but I saw it in the slides. At some point, disk drives are going to be gone, and it'll be the solid-state devices. For me, to move to a solid-state device, you know, permanently, I'd have to see it for a few more years and see how what the failure rate is. They did have quite a bit of issues about 10 years ago, and I don't know if they still have the same issues. Time tells that. So I talked about this. Don't forget the 2 forum posts and 2 replies, or 4 posts or 4 replies, or 3 posts and 1 reply. And the final exam isn't going to count as a post. All right. Let me go up there. It's worth a lot of points. I think it's worth 40 points. That's quite a bit. That's more than our project. It's equivalent to an exam. So be sure that you guys do that on anything of interest in the class, these discussions. They're quite good. I've been following them. Of course, I'm not going to count the team stuff. It's just these kinds of things, these questions that you guys have been asking. That's what I'm going to be counting. And you can see there's not a whole lot of them. Well, maybe there is. Yeah, that is quite a bit. Yeah, that looks all right. Let's look at the final exam. Remember, you want to reply to this model. You want to reply here so that they're all underneath there that I can see. These are great questions. I haven't gone through them yet. I wanted to wait a little bit. The only issue I had, I think, on Robbins was she only had 2 questions, and I require 3, but 2 is be okay at this point. I wouldn't worry about it. But if I have 3, I'm going to try and guarantee that at least one of your questions is on the test. That's the whole idea. And you'll have your name on it too. So we've got 1, 2, 3, 4. That's a good one, Karen. That'll drive people crazy. 5. 6. No, 5. Looks like I only have 5. 5 people. Okay. I just want to make sure that otherwise what will happen is if I don't get enough questions to choose from a chapter, because what I try to do with the final exam is take three questions. We've had 14 chapters, right? 1 through 15, but we didn't do 13. So we did everything else. So that would be 14 chapters. Divide 14 into 44, and you've got about 2 point something. 3, I guess. 44, 14 times 3 is 50. 42. Yeah, three questions from each chapter. So if I don't get them from you, I will have my own, which you won't get a chance to see. Okay. Before I leave this, are there any questions on the final exam? Questions? Okay, thanks, Mega. All right, let's discuss chapter 15. This is a cool chapter. So we're going to cover what the issue is, what are the threats from programs, cryptography, user authentication, that kind of stuff. And he's got XP as an example. That's interesting. It says how old this slide is, 2009. It's almost 9 years old. But basically, security really hasn't changed that much in the Windows architecture. To discuss security threats and attacks and the different kinds of attacks. So let's take a look at those. You got to consider the external environment, protect the system resources. You know you're going to have intruders attempting to breach security. Look at what happened with Expedient. Experian? Is Expedient? Experian? That financial institution? The Experian. Yeah. I'm sure, I mean, I think they said it was something like 200 million. Something like that. It was a huge number of personal data got out. Equifax. Yeah, it could be that one. I thought it was Experian, but it could have been Equifax. The threat, potential security violation, attack is to breach. An attack can be accidental or malicious. The accidental ones, you want to try and make sure that you handle those. The malicious ones are tough. Easier to protect against accidental than malicious. Yes. Oh, I should put that in my notes. I was going to tell you a number of short stories. I'll go through that one with you guys too. So breach of confidentiality, breach of integrity, breach of availability, theft of the service, or denial of service. Those are the different kinds of categories. There's a couple of others when I was teaching 108. These were in there, but there was a couple of others that they talked about. Methods, masquerading, breach, authentication, message modification, we'll talk about that, the man-in-the-middle attack, and session hijacking. So you've got your communications, right? Normal communications between the sender and the receiver. And the masquerading is basically the attacker is masquerading as the sender. Somehow they are able to squeeze in and do that. And then finally, the man-in-the-middle attack. I think you would see this. What do you think? Yeah, you could see these. I would consider this kind of an attack. You know those phony ATM devices that they thieves attach to an ATM machine. That's this kind of man-in-the-middle attack. They'll pass it through their hardware and gain the password, user ID, gain out how much money the guy's got in the account. He will do his transaction, and then they could go in and do it later. As a software engineer, it depends on what kind of development you're doing, Mega. What kind of development are you doing? You do have to worry about it. Yeah, I'll go through some software examples as a software engineer. Security measure levels. Okay, I love this physical one. I got to tell you about this one. It's a quick story. When I was working for Syntex Pharmaceuticals, Syntex was a very good company. There were two companies in the Bay Area in the 1970s and 80s that were great companies. Hewlett-Packard was one, and Syntex was the other. I know there was a third, Varian Associates. That would be the third one. Those three companies were the best to work with. They had the best locations up there in the Palo Alto Hills. The campus was beautiful. I remember we played volleyball at lunchtime on the greens there. But they built, Syntex built a computer plant. And what they did was, to the entrance to the computer room, they had a double door concept where you go in through one door with a pass key, and then you stand there for a minute or two, and then you use another pass key to get in the second door. Well, while you're standing there, they're weighing you to see if you're within the weight that's on the card, to make sure that you're not, taking or leaving something that you shouldn't be. I thought that was a little excessive, but that's a physical level. The other physical level I remember was at Jetstream Communications. We had our data site was off-site, so we had a rack at, I'm trying to remember the name of the outsourcing company. It was in Sunnyvale. I can't remember it now, but they had an entrance to the building, and then you had your own keys to your locked area of your servers, and Google was there. I remember seeing Google with tons of servers. eBay, maybe it was eBay at that time. Tons of servers at this location. Anyway, they had a finger identifying thing with your palm. You put your fingers, and you had to put them up against where your index finger and that's your second finger, are on these pegs. So you put your hand there, and then you slide your card, and your palm print basically would be your access with your card. So that's another physical kind of access that I've seen. And then, of course, you've heard of retina scanning and voice recognition. I'm not sure about on the voice side how good that is. Then the other levels are, of course, your operating system and your network. These are the 4 typical levels. And I agree, security is weak as the weakest chain. Okay, the different kinds of program threats. Trojan horse, these used to be pretty big. I guess I haven't heard too much about them today. But it's a code segment that misuses its environment. It exploits mechanism, allows programs written by users to be executed by other users. And of course we do have spyware, pop-up browser windows, and all that kind of stuff. I'm going to illustrate a couple of Trojan horses, I think, in our agenda. The trapdoor. Specific user identifies a password that circumvents normal security. And I usually call them a backdoor. He calls them a trapdoor, but most people back in the 70s and 80s called it a backdoor. And I will illustrate the backdoor to you as well. And it could be included in a compiler. Logic bombs. Programs that initiate a security incidents under certain circumstances. April 1st, I don't know if you've heard about that particular virus. Whenever April 1st came along, a certain code would execute at that point. Typically it wasn't harmful, and I'm talking back in the 1980s. Let's see, and this was the big one right here. The stack and buffer overflows. This is what really Windows sucked at. Was Windows, when they passed parameters on a stack, they never checked the length of the stack, so that basically you in your parameter list you would put code, and that code would be executed because it's in the data stack in memory, so it's going to get executed along with the privileges of that program, whatever it happens to be. And I think we'll see that in a little bit, how that works. And I guess I'll talk more then. Yeah, it's right here. It's the next one. Because you're using pointers, and if you don't check the length of your arguments, you can override the buffer. And if you look at, remember how programs run sequentially, that if you just set your binary code, so you would have binary code in here, machine code. You would have machine code being passed in this argument, so that eventually what would happen is a branch would branch to that machine instruction, and now it's in control and it's executing. And it's not something that the programmer put in there. It's whatever the attacker put in. Pretty bad stuff. So Windows had a ton of this going on. About every I would say this was now, we're talking from Windows 95 to about 2000. The reason why Vista was so late, Vista came out in 2001, but it was geared to come out in like 1998 or something. after Windows 98, and the reason it never came out at that time was because Bill Gates told all of his developers, stop developing and go and fix all of these issues, which he did. Well, the ones they found. And this is kind of a picture of what that is. So, and how things tend to grow in the stack. And so your parameters can fall right up into your area of code. I don't see too much of this, but I guess it's possible in the shell code to do this. Same concept. That's just illustrating it again, how it would work. So this is what it looked like before the attack. This is what it would look like after the attack. It modified the whole code. That's why we went through a lot of memory. Remember when we talked about memory and protection of memory and stuff like that? That's great, except when you're doing addressing of memory. As long as the program, these bugs here, these attacks, as long as they stay within the program's memory, the authorization of this program, it doesn't go outside, right? It doesn't do, like we saw an invalid reference, remember that, in our virtual storage address. As long as it doesn't do something like that, if it stays in a valid pages in memory, you wouldn't know it's happening. So we got viruses, code fragments embedded in legitimate programs. Typically they're very specific because they take advantage of the CPU architecture and implant basically CPU-based instructions. Operating system, and they try to target specific features of the operating system they can attack. And remember what they want to get. What would a hacker really want to get in the operating system? What would be the ultimate goal? Anybody? Yeah, that would be the ultimate goal. But how would you do it in let's say, the Intel architecture? What would be the goal there? Remember we talked about the modes of the CPU? Yes, that's right, Megan. That's what they want. I mean, if you get privileged mode, you can do anything. You can execute any instruction. So the goal of most of these hackers is to gain privileged mode. So that's what we've got to prevent them from doing. This was one I was going to talk about. This particular Visual Basic macro. Where this is coming out of is a Word document. And this was happening in the mid-1990s. Microsoft, with Word, Excel, PowerPoint, they all run with VBA code underneath them. That's the main command language in these programs. Do I have one? Yeah, I did. I had one. like developer. See, it's Visual Basic, and then you go into Visual Basic and you can add code. I've done this. Maybe I'll show you at some point if we have time. For when I was teaching Microsoft Word, Excel, I was trying to make sure that they aren't cheating when they're not sharing their code or their Word documents and stuff like that. So I wrote some code to make that very, very difficult to do. But you can do that. And it's underneath. This Visual Basic and VBA stuff is underneath all of the Microsoft products. And back in the 90s, Microsoft made a major mistake when they came out with, I think it was Word 95 or one of those around that time frame. They allowed execution of macros to occur. And stuff like this, what this is when the auto open executes this code, it dimensions an object, and they have the scripting file system object, which you can do anything with the file system. And this shells the command.com, which is the command processor, and it says, -K, meaning silent, you don't even know what's going on, and format the C drive. And VB hide means that it's in a window that's hidden, you don't see. So this clears your hard drive for you. What Microsoft did after that was whenever there's macros, let me show you. It's kind of interesting. Let me see if I can. I didn't think about bringing that up, but now that I thought about it. I was at Field for 10 years teaching computers and Word and Excel and stuff like that. Let's see. I don't see it there. I just saw it just a few minutes ago. Oh, here it is. Under my private drive that I had there. Yeah. Yeah, like the Excel test. I've got the solution, and I've got a copy. We can work on the copy, I guess. So let's open it. Well, let's not do that. I just installed a new version, and that's going to be the default if I double click, and I don't want that, so I want to open something else. Let's do it this way. That's an XLS. So do I have an XLS? Let me start Excel. Oh, let's do Word. That'll do it. Let's do Word. I'm using 2010 in this example. I have 2013, and I also just installed OpenOffice to see what that was like, because I'm going to be teaching Microsoft Office next quarter, CIS31, and I wanted to make sure that I get it all squared away. I haven't installed. I like 2010. I think it looks great. Okay, let's try to open that. You'll see the message. So I'm going to go and open that file. I won't open the XLS file. I'll open the Word test file. There we go. I hope this is of interest to you guys. See, I've taught a lot of different classes. Word test. Word test. Yeah, let's open this guy up. I didn't get the prompt, and I'm a little dismayed that I didn't get the prompt, because I should have. Yeah. But I'll show you the code. See, when the document is open, I grab their username from the environment, so when they log in, I get their username. And then I put their username in the documents custom properties area, and I say how much it's been opened. Okay, and then I add this text here. To it says word test in the header, and it did. I'll close this up. Close this up. See, it put word test, so I know that they ran the macro when I see that. And we can look at file. Let me think. What was it? The info properties advanced, and it's under custom. And there you see, I opened it. Linn, that's my sign-in ID on this computer. And if they had sent this file to another person, and they opened it and put their name in it or tried to submit it, I would look at the file and I could see, oh, this is opened by another person. So I would know that it's been copied. And of course, I would tell them when they got the message, which I'm not seeing. I'm not going to say this. I'm not seeing the message, which I should have. And that's what Microsoft fixed. They fixed it so that if a Word or any of their Office has a macro in it, you have to say, yes, please run it, or ignore it so it won't run them. Okay? That's how that works. Okay, other types of things. They try to use different techniques, like they'll try to put something in a file or in a boot record, or like we saw in a macro, or load something in source code that then gets compiled. They could encrypt stuff. I've seen that. They could tunnel in. Now, tunneling in typically is in the network area. And then this armored stuff is they put something around that you can't penetrate. Some programming languages, like if I were really going to write viruses, actually I wrote a program called HackMe. This was, oh God, in Visual Basic. I would say in the 1990s. I was going to kind of sell it, but the concept was it would start up, right? It would start up and it would prompt you right away for a password. And then you type in the password and it pretended like you were getting in now, but you really weren't. And then what it did was it went into the memory with a poke. You can poke memory with a lot of programming languages allow you to, poke in an address in memory and change the instruction set. So I would poke in a specific overlay, an instruction, and they would have to figure that out. The hackers would have to be able to figure all of that, and that was like step one. And I just said, well, I can't get through step one myself, so I kind of dropped the idea. But that's the concept of armored. Boot sector viruses. What they try to do, and a lot of our systems today are really protected from that. Let's see, did I catch everybody coming in? Hi, Bale. Yeah, I think I caught everybody and said hello to everybody. The way the master boot record works is you have an address pointer, right? And that's going to be what gets loaded from disk. Well, they try to hijack that and put in their file and change the pointer to their program so that they can basically watch what's going on, like a keystroke watcher, things of that nature. And those viruses were way back when DOS was around. People were trying to stick stuff in, which you could in DOS. It wasn't very smart. You could put a what's called terminate and stay resident, a TLR. Yeah, terminate and stay resident. In other words, you run it, but it stays resident in memory and can still run. I mean, even though it's been terminated. DOS was really strange operating system. Now, your worms, usually networks is where you're getting this stuff today, right? The internet worms. Port scanning. Have we talked about ports at all? No. This port stuff came in with TCP/IP, that protocol. Prior to that, I was on NetWare and some other LAN, Banyan Vines, other networking concepts, and then TCP/IP from the Unix side really got popular. It was an easy thing to implement, and people were implementing. Finally, Windows implemented it as well. And in Windows, it's the primary location. I mean, the one you really want to know is in your C drive, is in your Windows folder, is in your System 32 folder, and it's in the drivers folder. And it's in the etc. That came right from Unix, the etc file. Any of you guys know Unix or Linux? That was the etc file that they store a lot of their configurations. And there's your services file. And that's where all your ports are. So if you don't want somebody to be getting into any of these ports. Now your firewall actually has this stuff, but if you really want to make sure, you just remove some of this stuff. You be careful of what you remove, because some applications use these ports, and they can dynamically add ports. As you can see, there's quite a bit of ports. And this file gets read in by the TCP/IP program. It's the host services program. So let's see. The famous ones are FTP, port 21. You really don't want people FTPing into your machine, that kind of thing. So typically your firewall will block those ports, or not, depends on how they're set up. Okay, that's one, and the other one is your hosts. You know how your hosts are set up, and you got your local host, which is your loop feedback. Okay. I don't have any others set up on my machine, but I certainly use this because whenever I run my MySQL or any of the other, well, no, that's not true. SQL Server has its own port. But that's what he's talking about. And that's where it's located, in Windows. Okay, that's the port scanning stuff. Denial of service, I'm sure you've heard of this, right? This happens all the time. They attack a server, like Google. Well, Google has a lot of servers, but they attack a server from maybe 1 million machines trying to get to them. And you just can't. You can't service that fast. And it basically brings down the machine. And a lot of machines have limits on these. They'll have a proxy or something. This Morris Internet Worm. Remote shell, RSH is remote shell attack, or a finger attack. That's the finger. I didn't show you finger, but that's another one of those high FTP numbers. High meaning between 1 and 100 on the services file we just looked at. The finger is there. You can finger somebody. You used to be able to do that. A lot of people have disabled that. Like if I wanted to know if somebody was on the network, I could finger their address there and get them. Ping. Ping's another one. Have you guys used Ping? How about traceroute? I'm tracing my way to AOL.com. So I'm coming out of my router here at home. I'm going to this 10.10.10, which is set up at fairpoint.net is my internet provider. And there they're going to these various places. Looks like New York City. We're hitting New York. Finally getting to Yahoo. Yahoo. That's good. And finally we get down to yahoo.com. I don't know why it's down in Yahoo, but that's where the AOL machines must be hosted through Yahoo. That would be my guess by looking at it. So it finally hit their server here. So you could do things like that if they allow the traceroute command to work on their routers. It's always fun to watch. Now you guys could do that too. I bet you go through some gateway in Sunnyvale or something like that, or San Jose. Okay, let's see. That's that one. And you can use cryptography. I mean, it's done. And there's different strengths of it. And I'm gonna illustrate that to you guys in a little bit. And you base it on keys or login. Your login is like a key. I didn't show you the secure HTTPS. I think it's 440. Oh, My memory's failing me. I think it's 440 or 480. I think it's 440. .443. I knew I'd come up with it. So HTTPS, right? Our internet stuff is this going over through a secure where it encrypts the stuff. These secure socket layer levels. SSL, secure socket layer. So you know that whenever you have an HTTPS, you're fairly secure. And if you saw how packets got sent around, maybe next week, if somebody's interested, I have a packet sniffer. I could start it up and show you what packets kind of look like. They're really tough. I mean, you saw the route that I took, and that route might be different on the next time you go around because the way they send the packets, they could split the packets up and send them different routes. Tough to really break. This is cool. I really like this concept of encryption with keys and messages. And I want to share that with you because I wrote a program to do this. They're all different types of blowfish, all different kinds of algorithms. And there's two philosophies. You should understand that. Symmetric and asymmetric. Symmetric is typically you're going to use the same key. See, the same key is used to encrypt and decrypt. Okay? So I wrote a program here. Let me show it. This is all in Visual Basic. I wrote this program at Heald, when I was at Heald, because Heald wanted us to make sure that any student files that we stored on our machine were secure. So I wrote this program to encrypt files, and it didn't really encrypt them. It really, how could I say this? It really zapped the file. In other words, like a Word document or an Excel document, because they're formatted in a specific way. Well, I changed the formatting of it with my own codes. And so it has this password to encrypt and decrypt, the same password. This password, and like it says, last usage was encrypting. I store that in the registry of this machine. So let me encrypt something. So you would select your files to encrypt, and you can encrypt a whole bunch of files. That was the idea. Encrypt files. I could encrypt anything. I guess I could encrypt that guy. So let's open. Okay. And I just shoved the E and C on the end of it. And I could change the file name or whatever, right? And now I've got it selected, and if this file already exists, I would overwrite it automatically. So I'm going to encrypt it. And you saw how fast it was. Encrypted one file. Okay. And okay. So the last usage was encrypting. All right, so I would now go to decrypt. And it has that file. Okay? It has that file from the previous time. I believe I kept that in this program. Right? And you can decrypt the file, or you could edit the file name. I don't think I want to overlay it. I think I'm going to edit the file name. I'm going to select the file. Oh, yeah, that's right. Sorry about that. I have to select the file. And I'm going to call it 2. I'm going to call it 2. Okay. Now it's 2, and now let's decrypt it. And it's decrypted. Okay. And what we should do is kind of look at that folder. Let's see. I think this opens a folder. Yeah. Okay. Now this folder is where it's at. So the question is this guy the same as this guy? And you could run a program to check them, but I'm almost guaranteed they're the same. This says it's 20.9 kilobytes, and this one, I don't know. Let's look at the bytes. Let's look at the properties. It's 21,464. And this is the second one. And it's 21,464. But if you looked at the encrypted guy, let's look at its size. 21,479. Is that the same? Size on disk 24,526. It's a little bit bigger. Am I reading the right numbers? Yeah, that's interesting. Looks like the same size. I don't think it should be the same size. But maybe it is, because I can't remember how I wrote the program to encrypt this, but I'm pretty sure I changed the bits. That's probably what I did. I changed the bits so that like this could not execute. It would come back with an error. This file, it wouldn't execute. And if it was a Word document, it wouldn't be able to be picked up by Word. That's what I did. I remember. I kept it the same length. So it really isn't encrypted. It's just that I zapped some key parts of the file so that it couldn't be. And then I brought them back using this key, encryption key. And I think I used XOR for that. It's pretty simple. Okay, so that's that one. And that's using the same key. Asymmetric is really cool. It's a concept of a public key and a private key. And there's a number of RSA algorithms that will do this, okay? And I don't know if they show you an example. Yeah, they give you an example. It's mathematical. And it has to do with multiplicity and prime numbers. Okay? So you have a message and you use the public key to encode it. And you would give everybody your public key. Okay? You would give them this file. And then they would encode the message, send you the message, and then use your private key to decode it. Okay? If your randomly prime numbers aren't large enough, this could get hacked. But if your numbers are pretty large, it's tough to hack. And I go through this example because it's a cool example and it works really well. Okay. With that, I was going to actually put this out for purchase at some point. This program. It's called Secure Send and Receive Files. Okay, so I have a public key, so I would load the person's public key. It's a file name with their public key. And you can see the key. I'll show you the keys. This is how you would create the keys. So you would have your public key, and it looks like that. And you'd have your private key, and it looks like that. It's XML-ish base, okay? And it's big. I mean, and it's all alphanumeric, okay? As you can see, it's all alphanumeric with special characters, but there's no binary. There's no binary data in this thing. It's all, in other words, there's no carriage return line feed in it, like a Word document. It's all like one huge list of alpha code. And then what you would do is, if you wanted to copy your public key, you could copy the paste and stick it in a text file and send it to somebody. I'm not going to create keys because they go into the registry. But I've got it set, and I was going to do a message for you. So I'm going to use a public key that I give somebody. So let's, this is a message. We have Mega, Albert, Dale, Daniel, and Karen, and Kane. Okay, so I'm going to encrypt it. I'm going to encrypt it. And that's what it looks like encrypted. Nothing but textual characters. You'll see, and this is using RSA, I can't remember which version of RSA it's using. Okay, so now what I'm going to do is I'm going to copy the message. So this is what you would do. You have your encrypted message, you copy to paste, and then you'd paste it in an email message. Okay, so you would have somebody would give you their public key. You would do the message, send this to them, and then they would use this program to do this. Paste it in, paste the encrypted message. That's what we just created, was this guy. Okay. So now we're going to decrypt this guy using the private key. Are you guys with me? Okay, let's decrypt it and see if we get the same message back. This is the test message. Mega, Albert, Bayo, Daniel, Karen, and Kang with us this evening. Well, you could do files as well. See, you can use a public key and encrypt the source file. So let's browse, and I have some test files in this folder, like source text. Let me show you the file. You'll be thrilled with this, what this source is. It's the Declaration of Independence, okay? But it can be any file. All right, well, I'm going to have that now. I'm going to encrypt the file. And I usually have something called source encrypted or something. Source encrypted text. So we'll use that and we'll overlay it. And it prompts you, do you want to overlay it? Yeah, I do. I want to overlay it. And then you can encrypt it. And it was successful. So let's just browse for a second, even though we're not going to do anything. And this is, let's find the encryption one. This is what it looks like. The Declaration of Independence looks like this, encrypted. And you notice I do some extra stuff here. I put in my code so I know that when I decrypt this thing, it's running my secure send in what version, in case I change versions, right? I want to be able to back level. And then I've got a code here, and then this is really the start. Oh, actually, no, there's something else here. I've got let me think of what I have here. I have some kind of code in here. I can't even remember. So really, if somebody were able to even decode this stuff with a long time, they'd have to also figure out what I did here. So it adds some complexity. All right. Well, let's try to decode it. So that was that. So let's decrypt it. So I'm going to get the encrypted file we just created, which was this one. And then let's unencrypt it and restore it. And this is the restored one. And yes, we're going to overwrite it. And let's decrypt. Decrypting takes a little bit longer than encrypting for some reason. And I'm using multiple threads in this program. In other words, what you're seeing is there's probably 5 or 6 threads doing a piece of this at a time to make a better performance. So let's look at that. And see what the restored file looks like. And it's the Declaration of Independence, all the way to the end. And remember, there's carriage return line feeds here. So it does binary. It does binary beautifully. So it doesn't have to all be text. It could be any binary. Because what you're seeing is carriage return line feeds, and they are there. Okay, well, I thought you'd be interested in at least seeing that first. It's done by characters. You know, it's binary. It's done binary. I'll just say that. The difference is the encrypted code. Let's go back to this. Let's put in another message. Maybe you can see that. Right? So let's encrypt it. All right. Let's copy this. Let's decrypt. So I've got to select everything here. See, the carriage returns, they were picked up fine. It's all binary. But the thing is, there's no, in the encrypted message, there's no binary type thing. It's all textual based. In other words, it could be into a text, be placed in a text box. So let me copy that and open up and see if I can illustrate what I think I'm talking about. All right, now I was going to turn off word wrapping, but all of this, there's no carriage return line feed here. There's no carriage return line feed here. It's all text. And for a minute. See, it's all one line. That's what I was trying to tell you. See, it's all one line. And there's no funky looking character. See that? There's no funky looking. It's all within ASCII 32. Well, there's no 32 because that would be a space. There are no spaces in here. So it starts at 33 and goes to 127 in terms of characters. Okay? You can see they're just all regular characters. This would be tough to decode. It would really be tough to decode. You'd have to look at how things are done. Okay? You could figure it out at some point, I'm sure. Well, it took a while to write the program, but at some point I was going to market this, and then I thought better of it, and I said, well, suppose some terrorists bought my program and started sending messages, I would be supplying them, and, you know, would our government be able to figure out how to break it? I don't know. Maybe. Depends on how good they are. That's asymmetric encryption. It's pretty cool. Gee, how could I explain this better? I don't know how much I want to put on this, but let me just go to the code because I can't remember. I mean, I haven't worked on it in a while. I have different versions of it. This is without threading. This is I don't know what I was doing, and this is with threading. I believe I was using threads in this one. And I don't know which version of VB I was using. Shoot. I might have been using 2012. Let me see if I can open the 2012. I'm teaching 2017 now in my previous, you know, in 14A. If you haven't taken 14A, Visual Basic, it's fun. It's a good class. I teach about how to develop. I was a developer for many years. I'll share some stuff with you tonight too, for an example. Yeah, this one has 3 projects for some reason. I can't remember why. Well, while this is thinking, let's go back to our presentation. Okay, so we kind of went over the encryption and the decryption, and I'm using RSA, and I'll tell you which version of it. Oh, I think it's 64-bit. I'm using 64-bit. You really want to use 128 or 256, but that's really a lot of crunching, and that's the problem with this type of system. I can only decode or like files that are less than 10 megabytes. If it's larger than 10 megabytes, I won't encrypt it because it takes too long. Even at 64-bit prime numbers. Hashing. SHA1 is a cool hashing mechanism, and I learned that in Perl back in the 1990s, mid-1990s, when we were using this. The idea is that you take this huge number and you hash a key to a huge value. That's this guy, and that becomes your session ID. MD5 I use on my databases. MD5 is a one-way encryption. In other words, you take a set of characters, you encrypt it, and you store the encryption. And then you, the person would come in, you would encrypt it, or decrypt it, excuse me, you would encrypt it and check it against what you stored. And this is really solid. I haven't had much issues with that. Tough to break. And when you look at it in the database, it's encrypted, so you don't know what the actual password is. So for those developers that want to know users' password, it doesn't unencrypt. There's no MD5 reversal. So that's what makes this pretty powerful in my mind. From a development perspective, you don't want programmers going into the database, looking at the data, and getting users' passwords. Digital signatures using RSA. This is pretty cool. Same thing, same concept. Sometimes when you have a bunch of keys, you can store them on a structure called a key ring. But you've got, like any of these things, you've got to be careful on what keys you're distributing. In the asymmetric case, the public key is what you want to distribute. You never want to distribute your private key. And in my program, not this one, this one, I have in there, I've just started writing this help stuff, explaining it, and then finally I just say, always keep your private key to yourself. Don't lose it, or you will not be able to decrypt any message. Okay. So that begs the question of, well, how secure is where you're storing your keys, right? In your operating system. And it just goes around and around. This is an example of a man-in-the-middle attack. Using the key, grabbing the key, and getting in. Anytime you're able to do that, you can get in. I kind of talked a little about secure socket layer to you when we talked about sockets. Passwords must be kept secret. Frequent changes of passwords. Use non-guessable passwords. I want to stop here and tell you a story. Let me see in my back. Yeah, it looks like this is yeah, I'm using the threading model. on this concept here. Let's open this one up. So I've got a callback to my main program that calls back after it decodes the record. But what I wanted to show you was, yeah, it's using this concept here where you have a byte array. And that's why it's an array of bytes. So it fits. And that's why you can do any character. But the algorithm always returns string characters that don't you don't have issues. Okay, that's how it got it. I couldn't remember. It's a byte array. Does that help, King? I think you asked that. Maybe Mega asked. Okay, I want to show you this in a second. Sample of asymmetric algorithm secure. I showed you that. I talked about the words macrovirus. I showed you that. I didn't talk about Anacornicova virus. This hit in 2000, and when it hit, it brought down half of the country's email servers. And at the time, we were using Exchange, which is Microsoft's product. And let me tell you the bug here. This Anacornicova virus, I grabbed it and I decoded it because it's a Visual Basic virus. But the issue in Exchange was that when you had a .vbs, that's a Visual Basic script, .vbs, and that would execute the Visual Basic language, you know, the VBA code, but it had another dot on it. It had .jpeg, .vbs, and Exchange only showed you attached files that had a single dot. In other words, Exchange at that time had this file called, oh, I don't know, Anna, whatever, XXX, and then it had JPEG, or one of those, JPEG, and then it had VBS, but it only displayed this much of it. Exchange had a bug in it where it didn't show you other extensions. And so when the user sees this picture, double clicks on it, and it runs this program. And what the program did was it went into the Outlook's address list, grabbed all of the global addresses, emailed everybody on that list, and attached this file to it. So imagine a server, you know, with 200 people, you know, right? And then they send it to 200 people, and then they send it to 200, and they send, and it brought down Exchange servers, and then it went out of the building because it went to all of our customers, all of their, you know, contacts, any contact that was in that contact list. And it went through the country like a wildfire in a half a day. We had to bring our server down as well as a lot of other people. And I would say half of the United States on that day lost a half a day's work. So what we did to rectify it, well, Microsoft came out with a patch that fixed this issue. And what we didn't know, and I didn't know at the time when I was the director there, that you could add a do not allow onto your list, and VBS.VBS, it would have caught this. Okay, it would have caught this extension in that do not allow attachments concept. And a lot of systems today, like you can't attach an EXE to Vianza's mail system. It won't go through. And they have, you know, .com, .bat, .vbs. All of those extensions are disallowed for attachments on a lot of file servers, mail servers especially. Okay, I'm not going to talk about the contractor issue. That's something else. This goes to the thing I was kind of talking about before. And let me go back to the presentation. When you develop systems, usually you have what's called a production environment. That's what's running that the users use. You have a development environment that the developers are in. You might have a training environment to train your new users on how to work the production system. All of these have separate databases. It's the same database structure, but they're different databases and have different access. The programmers have access to the database and the code here in development. The production people have access to the production data, but not to the programs. And they're the ones that are doing payroll and all of those things. And it's a separation of responsibilities, typically, you have in any big company. And finally, you have a testing environment. So what you would do is you would develop the thing, you would test it as a programmer, move it into testing to have the user test it, make sure it does what they want. You would then copy it into training, so now it's a part of training, and then you would copy it into production, so now they're using that live. And a lot of companies have these 4 environments. But at Syntex, what we did was we had a tool. We had our database was total at the time, total database, which was a doubly linked list concept back in the early 80s. And we had access, we had a program that we could run against production data if we had to fix the problems with the data, because programs have problems, they corrupt the data, you have to go in and fix it. So we had a tool, and for the longest time we never told auditing about the tool. So years went by. Finally, I think it was in the late 80s, we had a computer security guy hired that was now doing computer security, and this became a big issue. No, you can't have, you can't allow the developers, the programmers, to have access to production data. That's a no-no. So what we did have was we had a tool that we would ask and request from production to have access to that database for a short period of time to fix it. So it became a record. You knew about it at that time, and then you knew what was happening. And that's how we fixed that issue. But a lot of people don't like programmers touching production data. Okay, that's a long story. User authentication. That's the last story I was going to share with you from this case. Well, no, I've got one more. Are you okay with this? Are you guys getting some value out of this? Okay. I was at Arbor Software. I was the director of Arbor Software. And we had something like, I don't know, 200 laptops out there. We had like 220 employees and 200 laptops, and maybe, because it was a software company, so we had a lot of computers. And I was worried about these computers getting hacked. So what I did was I ran a program called Crack. And what it does, it reads the security access file that's in Windows. And that's where it stores the passwords in this file. And of course, only administrators can access the file. So that, and of course, the IT department was the administrators of these file servers. So I authorized one of our engineers who was managing these servers to copy the file, put it locally, and run Crack against it. And within 2 seconds of Crack running, it had 95% of the passwords cracked. And I guess you would know which one was the #1 password used. It was password. So what I did was I put out an email as from the IT department, right, as the director of, and I was responsible for this kind of security, that you guys need to change your passwords from password to something more rigorous. All right. Now it was running for 2 days, and it never cracked my password. Do you want to know what it was at that time? No, it wasn't password 2. That was good though. No, it was this. Let me see if I can remember it. Let's see. It was that. Well, F to C. Yeah, what it found was it did find the C, and it did find the F, and that was it. The rest of the stuff it never found. So if you want a secure password, that's pretty good. Use a formula. Okay. So let's go back to the presentation. And I talked about the encryption, MD5 and stuff. And you can implement all different kinds of security. You almost today have to have a virus protector on your machine. I use McAfee, and it just ran, or it's running or something. Yeah, it looks like it's running a scan, and that's why I'm probably running a little slow tonight. And it only completed 1%. I have a pretty big drive, so it's going to take a while. And then, of course, you have firewalls, right? I'm not going to spend a lot of time on that. You might take a class on that at the end. The Department of Defense has quite a number of classifications. They have numbers within, so depending on which classification you're in, you could have numbers 1 through 5 or 6. I worked for the Department of Defense. My first job, both part-time and full-time, was for the Department of Defense when I was at college. I would do full-time during the summer, and then I would do part-time during the time I was in school. And it was called DCASR, Defense Contract Administration Services Region, DCASR, San Francisco, which happened to be in Burlingame. And it was in the 1960s. And I guess you know what was happening in the late 1960s. Anybody know what was happening in the world with the United States in the 1960s, the late 1960s? Yeah, the war that no one respected any of the soldiers when they came back. Yeah, the moon landing was in the late 60s. You're right about that, but it was Vietnam. And when I worked for the Defense Contract Administration Services region, the department paid the contractors for putting things, you know, overseas. So there was a lot of lumber contracts that went, and I had what was called, I'm trying to remember, they had 4 levels down. This looks much more complicated because it's got computer stuff now. But back then it was top secret, secret, classified, and confidential. And I had security of confidential. I was the lowest. I didn't have access to anything. So if I ever saw something that was stamped top secret or secret, I could not open it. That was my responsibility. Okay. Of handling. And I ran across one document that came across my desk that was secret. And I gave it to whoever was supposed to have that clearance. Okay, I'm kind of done with this now, because now we're into Windows XP. How do you acquire security clearance? Go work for the White House. You won't be there long. Oh, what was it? Jared Kushner, right? He had supposedly top secret security, but they took it away from him. You get reviewed by the FBI, and I believe the FBI determines. And the same thing with me. I do remember when I took the job, I had to give fingerprints, palm prints, and then the FBI did a background check, but a minimal background check. I mean, I was a student, right? And so I didn't have really a lot. I had no work experience. So they just checked to see if you're a student, have you been in prison. They check those things, and if so, you pass for the least. In that case, it was confidential or something. Yeah, it was pretty easy. Okay, I wanted to show the security on my church. This application I spent with another a student of mine. We developed this in let me think, in PHP, MySQL, and of course we used HTTP and AJAX, those mechanisms. And I did have a little Visual Basic in there. So what I wanted to do was start it and show you some of the things that you want to do in an application. I showed you this. I'm going to go to Users, and I'm going to go to my desktop. I could go to the desktop, but this thing over here is hiding it, and so I'll do it this way. I have all of my not utility tools, my programming tools somewhere. Okay. Oh, right above it. Okay, I'm going to start up WAMP. WAMP starts Apache and PHP and MySQL, and I bet I just lost you guys. Yep. Okay, let me get you back. Are you guys back? Yeah, what happens is whenever you do a screen resolution change, it wants to clear, and that's what happened. It went to screen resolution changes. Okay, so I started it. It's running. It's right here. So you can see that you've got. That's why I like WAMP. It's really cool. And I'm going to the server, and on the server you can see kind of what's available, what's loaded, the extensions I have loaded for Apache. And I don't know if I want to. We'll leave it. I'll put on a new tab. Now that it's up and running, I want to go to the application. We have to find the link. Okay, and I'm going to log in as not the admin, but the admin. In other words, I have the admin is the administrator, but I also have another sign in so that I could set things up for the system itself. It's the super password guy. This one allows you to administer the system as a user. Okay. But what I wanted to show you was, let me see. Oh, the security. That's what I wanted to show you. The way I developed it was each module, so each PHP program tells you kind of what that program does, and if the program is on the menu over here, is on the menu or not, and whether that group, this group is the admin, but I have the pastor group and the test group and the contribution group. You could have any groups you want and you add them in, but in that group you would assign these programs. And there's 224 of them, so that the user could customize the access. All right? And now, as the developer, I would come in on a different ID, and I could actually add a new program and set up whether it's allowed to be on the menu or not. And then they could then add that feature into their system. So as a developer, I could use this as well. They can't add any programs as the admin. All right. What else did I want to share with that? Your system. You could back up the database. Where's that? Where's yeah, there. Database backup. So you could take a backup of the database if you wanted to, and then from a backup you could restore. So only the administrator can do that. All right. So what I wanted to show in this was, this is a tool. It's a PHP MyAdmin that allows you to access the database. Now, I didn't show you the structure, but you see I have development in front of this. And this is the major configuration file for the system. And the prefix would be set to production if this is a production system. So I have that concept of production development. And if we needed a training system for users, we would have a training system. It's pretty easy to do. Okay, so that's that piece. So all of my database, I could have it all. I could have a production, my church database. And what I wanted to share with you is this, the security feature authority view. Right, we'll take a look at that view. And that's what we saw. These are the 224 records that we saw. Okay, and then the users, security users. I wanted to show you the passwords. This is their login password. And it's encrypted with MD5. That's what MD5 would look like. And if you notice, they're all the same. So what does that tell you? They're all the same passwords. Because it encrypts, it has to encrypt them to exactly a unique number. Well, here's another exact unique number that's the same, so it's the same password. All right, and the I don't see here. Let me see. What I don't see there is the number 1. See how it says the security user? SU stands for security user. I have a naming convention that I use for all of my databases. SU is security user, so all the fields would start with SU. If it's people relationships, it would be PR or PD. And in the case where we have duplicates, I'd go 3 levels, you know, ABC kind of thing. Let's see, what about that? What else do I want to say about this? Oh, yeah, there's a document. This is the security and features document that I produced so I can remember what the heck it is. And just showing some examples here. But it explains here somewhere. Thought it was in here. Yeah. Oh yeah. There's one special user, sysadmin, with ID 1. And the purpose of this sysadmin is in case the users ever deleted something, you know, on the security file here, in case they ever deleted these guys, which they possibly could do. I always have that, and that's in code. That's not here. You see that? That's not in the database, as you can see. Let me see, make sure that's not in the database. No, it is in the database, but you can't delete it from the system perspective. You could delete it here because it's a tool to access, but in the this is a view. I forgot. The security users is a view. It's not a table. It's a view. Okay, and you don't see it in the view. I don't let it in the view, but we could get in with that password. So the sysadmin with looks like the same password. I'm pretty smart that I don't have multiple passwords, because once you forget the password, you're not going to be able to decrypt that. You would have to reset it. You'd have to create a new user. But let's say the user did somehow screw this up. I have an emergency fix that uses this sysadmin concept. So let's minimize that. And I'm almost out of time with you guys. Did I do the question of the day with you? Ooh. We should do that. Well, yeah, let's do that. Thank you for reminding me that. My wife just reminded me. She's good. Yeah, everybody said over here, not yet, not yet. Come on, let's do it. Okay, what example of cryptography did Art illustrate this evening? What method was this? What method did we use? You can barely see it, but it's this word right here. Not symmetric. It's the other one. Let me try it first. Make sure it works. Oh, it's golden. It works. All right. Okay. Hang on 1 second. I'm going to do one more thing with you guys. Since I'm on a roll. I'm going to log out. Oh, the other thing is on this setup stuff, you can, as the administrator on the system, you have all of these settings that you can set, and the one that I wanted to show you is whether the system is available or not. If you turn off the system, you would give a message, okay, and that message would display. So it's a good way to manage your system. Maintain it if you have to. Okay, I'm going to come in with sysadmin. And you notice that it's got a lot more stuff. It's got everything, because this ID can go everywhere. And the util, and then the system, and then it can do stuff in the security area, like this guy. I can add new security elements if I want to. So it's a nice mechanism. We never went live with this. It just got too complicated. and we missed the window of opportunity to market this. Okay. I think that's all for tonight. Do you guys have any questions? I hope it was of interest to you and you learned something. Any questions? Got 2 minutes? 3 minutes? No? Okay, I want to say goodnight, and this is Thursday, so that means that it's the weekend. Have a good weekend, guys. Thank you. Thank you for participating. I appreciate it. Okay, have a great evening. Oh, yeah, that's my wife. She screams.